All right, so this is going to be round 2 of my load testing my API. This time it's going to be for my engines API. And basically the difference of this is going to be, I want to show an example as to why we don't just want to create a backend where we send thousands and thousands of requests at a single endpoint without any kind of queue or messaging bus to accommodate for that. So I'm going to show you pretty much real world like performance implications if you were to just do it this way. And also, can we acknowledge the fact that I have 29 gigabytes of RAM currently in use of my 36 gigabytes total. So, I would not, if you're looking at getting a Mac, I definitely would not get anything less than 36 gigs of RAM for sure. So I'm going to let's close up my activity monitor here, and again, this is my engines API. So the specific endpoint that we're going to be hitting today is going to be this post data. And before you say anything, I know it's a GET request. Well aware of that. It's just for this is just for testing because I just want to basically test my my sync engine pipeline that we set up in a previous video. So if you want to see that, you can see the video. But yeah, I just want to basically send a fake engine model through that pipeline and then just return something. But basically we're just testing, what's the latency going to be like, and I'm going to show you basically how it's going to break down as we increase the requests. And basically when this is actually going to be used outside my prototype, I'm going to allow it to pass or post data of the actual engine model that's going to have all the specs and stuff. So that's running, and let me have a lot of windows open here. So this is the API itself up and running. So this is just the Swagger UI. All right, it's just like the gives you this nice UI for all your endpoints. So this is the post data. So we're gonna execute that, and a bunch of times it returns tests, so we know that it's going through. Good, and if you don't believe me, I can set a breakpoint on this. Let's execute it again. And we are going to hit the breakpoint here, just like that. And if we step into that, we go to our service, and then we build the entire engine block, so the data pipeline, and then we send the engine through that. All right, so we're sending just the fake engine that I made with fixture, so a bunch of just fake data, and then I'm going to receive that back from my pipeline, both of which are asynchronous, and then I'm just going to return test. I don't need to return anything, but I don't know, we're returning test. So, and that's where you see test right there. So that's it's going through the process. So let's go ahead and pull open JMeter yet again, and I have tweaked the configuration since last time. And if I can get my windows out of here. Hold on. I'm on a widescreen, right? And I can't share the whole thing, otherwise it'd be like crazy small. So this, what was I showing you? JMeter. So I've tweaked it a little bit from last time. I'm now pointing to my engines API, so that post data endpoint I just showed you. So different port number, still on localhost. And I'm just going to start it off doing oh, no, I don't want to do 5,000. I don't have 5,000 users. Let's just do 5 requests, how we started it last time in the last test, and let's go ahead and run that. Oh, hold on, let me get my breakpoint out of there. That's going to mess up my test. Hold on. Let's go ahead and clear that, and let's run it again. And then you go to my... okay, right, so I put 5 seconds kind of delay there, so those are all successful, and we should see back test like we do there. And I figured out latency is there, 98 milliseconds, 110 milliseconds. So it looks really good. I'm assuming that's milliseconds. That's usually what it's in. I would definitely hope it's in that. So 5, and then average 100 milliseconds, and then max of 127 milliseconds with a 0% error rate. And a general throughput of 1.2 messages every second is what it is. So that's what that means. And I'm going to go ahead and bump this up to What should we do? Why don't we do 2,500 users? So all of a sudden we have 2,500 users all sending their engine specifications up to this engine endpoint. And again, this is just one single endpoint hosted in our engine's API microservice. So let's just see what happens, right? So we have a ramp up period 5 seconds, and we're not gonna loop. Okay, let's save that and let's run this again. Let's go to our results. Okay, so immediately we're like, what is happening, right? We have a ton of errors, and we have like interspersed successful ones. We have a whole bunch of successful ones now. So we sent. Okay, so it's still sending samples. So we have a 66 point. We have 2/3 error rate. We've not good. But let's go ahead and go back to our endpoint here, and let's see how long it takes to actually call it from another spot. So you can see it's taking a very, very long time just with adding 2,500 users trying to hit this endpoint. So it's still successful. We're still getting a test, but you can see how long that's taking, and our test must have stopped. Yes, it did. Right, so our test stopped, and we can see how quickly that returns back. But in the middle of that test with 2,500 users, each sending a request every 5 seconds to it, you can see that basically destroyed their entire endpoint. So the temptation is here when you let's go back to my last video example, right? This is the same exact type of endpoint under the hood, right? It's still a typical just .NET API controller. It's just they're both a GET endpoint, basically identical routes. We're not posting data to it, but this one is basically essentially is doing nothing, right? It's just returning an object, and we're not really working on it. We're doing a basic filter, but that's it. And we hit it with like 8,000 users, or I think 5,000 to 8,000. I forget what the number was. However many threads I could handle on my machine with a 0% error rate. So it was all successful. It was good latency, and we had no problems. So the temptation is to say, okay, if this worked really well, then we would suspect that this one would work too. We're not doing a whole lot, it wouldn't seem. We're just posting data down to our service, down into this pipeline that we've kind of created, which all that really is doing is just composing functions together, which aren't even doing a lot. Basically, they're not doing anything because this is just a prototype kind of stubbed out pipeline, which it's not sending data anywhere. It's not requesting data from any other APIs. So it's all contained in this chain of methods, and then it's returned back. So you're like, okay, it's like we should be good, but not really. So if we go back to here, this is just one example of some error rates. So we're actually getting, is that? Let me clear this because I think it must have wiped. So let's go ahead and run this again, but let's go ahead and increase the number of users to simulate, a real day-to-day activity. Let's say right in the morning we get 5,000 users on our system. Let's see what happened. So 5,000 users, ramp up period 5 seconds, and let's just run it. And we're gonna put on infinite. We're just gonna keep having the users send a request every 5 seconds. So let's go ahead and save that, and let's see what happens. So immediately, we're getting some errors, mostly errors. We're getting successful. We're getting errors. So we're saying we're getting a socket exception. Crazy stuff is happening, right? So we're getting this is not good. So if we go back to our summary report, we're seeing over half of our responses are erroring, which is completely, is not acceptable for any kind of use, outside of a development environment. So in a production setting, that this would mean, okay, in the morning or whatever, 5,000 users are hitting our system. Over half of them are going to receive intermittent errors, and that's not good. And you can see it's just happening again. And if we go back into our if we try to hit their API again, we're going to see how long it's going to take a single request from another client, and what are we at, 4 or 5 seconds, 6 seconds. So it pretty, okay, load failed. So we didn't even get, wait, did it respond? I don't know, did it? I don't think that went through successfully. Let me try it again. Type error, load failed. So I don't think this is even, this is not going to return successful back. And this is still running again, right? And we're not seeing any successful. And you can see our samples is going up, our samples is increasing, our error rate's holding at 82, 83%, and we're still not getting anything back, and we're at over 10 seconds now. So we broken our API with not even adding a lot of users, right? So this is exactly presents why we need to engineer our backend in such a way where we are able to process a very high throughput of messages in a way that they're able to process and that it's not going to break the backend, right? We can't even hit this API, and that took like 30 seconds and it returned back an error. So let's go ahead and stop this and let's see if it. Okay, so it shut down all my threads. I sent 36,000 messages. 88% of them errored. That's not good at all, right? So this, again, this is a prototype type build, right? But this is a completely valid way of like creating a data pipeline using propagator blocks. It really presents what I'm trying to guess. I guess what I'm trying to get across is, just because you split something into its own microservice, and you can scale it, you can do whatever you need to do. Doesn't still is not going to guarantee that you're not going to get errors back from that endpoint, right? There has to be some other design pattern that you implement, some kind of messaging broker, a queue, or whatever it is to throttle, how many messages are being sent, right? You can duplicate your microservices and then put them behind a load balancer to like kind of route requests depending on how much traffic. You can go that way too. There's a little bit more, it's more stuff to set up, right? Like you have to just think through that. But this is a reason why you need that, right? We can see very quickly in like 30 seconds, it doesn't take much to have a single endpoint begin to return intermittent errors. And not only are intermittent errors, you're not going to be able to replicate that just, stepping through the code just randomly, right? It's just, that's why they're intermittent. That's why they're the hardest to track down. So, but if we, obviously if we were to take out basically all the work that it's doing, right, we're going to, let's not pass data to this, sync engine data, whatever, then yeah, it'd be fine. And I couldn't even imagine if we were trying to post data to a database also in this endpoint. So it's like one endpoint's acting on data and posting it to a database. It would start failing so quickly. And, that this is where like distributed systems really come into play is, okay, how are we going to route requests to an area, or how are we going to contain them in this bus that we can throttle up to the endpoint. So I thought hopefully this was an interesting look at an endpoint breaking and like what you may see happen if you send just too many requests to your endpoint. Again, I got sent about 38,000. What was it? Simulating 5,000 users. Now 5,000 users sounds like a lot, just for your own project, and you'd be like, oh, you should be fine, but in a production system, 5,000 is not a lot at all. And obviously, I know I'm just on one machine, so it's like, well, if you host it, it should be fine. Well, maybe not, because you need to guarantee that with such a small number as this, you're still seeing, 100% success rate. So we're going to come back, and I'm going to add in some code, not in this video, but another video, to basically show you how I'm going to eliminate such a high error rate, because we can't change the logic, right? We can't change what I actually need to do to the data. We can get fancy and break those off into other endpoints, which I may have to do. But I'm going to go ahead and implement the message broker that I need to do, and then put that in the layer before it gets here, and then go from there. So anyway, hopefully this was interesting. This is about as real world example as you can get, like just diagnosing and doing these things. So yeah, so let me know if you have any feedback or anything. But all right, I'll see you next one.